Hello everyone, it's November 16th. Alright, so we tried yesterday, it still didn't work. Man, this one is so hard to crack. I think there is definitely, room for improvement. I did make it a little bit more complicated than it needs to be, just for performance purpose. Maybe we can, get it a little bit simpler. I mean, honestly, I have no clue, man. I have no clue. It doesn't really. I feel this should be right, but it's not. And I know the solution is quite simple, right? The solution is quite simple. So, I don't know. Maybe we should. Yeah, I see. Like we are on the right track, but I just, for whatever reason, it didn't work for me. I think I will try it again. Just for the fun of it. Need to understand why this is wrong. And maybe we'll figure it out. Output is 6. Jesus, come on, man. That was pretty bad. Let's see what we have today. Now we'll decide. Oh, it's an easy question. Okay. I think the chances are high that we can go take a look. So we have nums. Integer k, return true if all ones are at least k places away from each other. Otherwise, return false. Okay, is 2. So we just need to take this. We don't have to consider overall. Yeah. Alright, so we'll just smash through this real quick. And then we will go back to yesterday's solution, at least run one round. I probably will go through my logic again. I think yesterday when I was doing it, got a little bit sleepy and then things didn't go very well. This one should be very straightforward. What we do is we'll record the previous, right? We'll record the previous, and then once we have it, we'll compare. So I can say pre is gonna be int min. Okay. Then for int I is 0, I is smaller than plus size, I plus plus. Okay. And say if. Oh, I actually can do this. So pre shall equal to, say nums 0 is equal to 1. If it is 0, otherwise it is. And then for here, I can start with 1. Right? Let's say if nums I is equal to 0, or not equal to 1, and the distance, so I minus pre minus 1 is smaller than k. So we can be k, right? At least k. If smaller than k, then we'll return false. Okay. Otherwise, actually this is not the right approach, because we will do this. We'll do a different way. Okay. So if this, then we return false, right? Otherwise, which means it's larger than, then we don't have, then pre equal to I. Then we move on. And if it's 0, we just move on. And at the end, we return true. Okay. Let's take a look. Solid? Actually, I'm not sure. There are some edge cases I haven't considered. So I think minus k will be good. Right, minus k I think will be good. Because it's gotta be... Actually, minus k might not. It's minus k 2 times k. Because if it's minus k minus 1, it can still smaller than k. But 2 times definitely I think should be fine. Yeah, 2 times is fine. Alright, so this one's good. Let's move on to this one again. That's, I think it's 15. So the idea is we're currently looking at a 0, right? We're currently looking at a 0, and then we need to find the previous 0. So this is the previous 0, right? Previous 0. This 0 is not included. See, that's the issue. Maybe you should push it in, and then we just starting from this, we do these two, right? We have this is the 1, and then we do this, and then we do this, and then we do this, right? We slowly... Yeah, maybe we should there's no index. Oh, there is an index. No, there's no index. We use the 0 indices, so there's no index. We just need the total ones at that position, right? The total ones at that position. Okay, so let me do a little bit change here. The total ones at that position, and the x ones towards the right. Okay. So count is we need to return. So we say current index is going to be 0 indices dot back, and then for this it's going to be minus 2, right? So it's going to be the previous index. This 0 is not included. Yeah, so we're looking for the ones between, and the 0 count is going to be from, it's just going to be j, right? J. So j is going to be this minus 1. Actually, it's a minus 2, right? So if this minus this is going to be this, so it should be this one minus 1, right? This one minus 1 has a number of zeros. Okay, number of zeros. Okay. Teeth? All right, so I have 0 count, and then if it's larger than total, that means we cannot do. This is all fine. And then we have 1 count. Okay, 1 count is how many ones we have in this range, which is so we don't have index, right? We don't have index. What we have is current index, right? So we say current index minus previous index. So if it's 0, 1, 2, 3, 3 minus 0 is going to be 3, and then minus 0 count. So we have, this is the number of ones, and then the ones required is, we have 0 count squared minus the extra ones. So the ones required for here, and the number we can have is going to be the 1 count, right? If I have 4 ones and 2, and then we can only do 2. So yeah, this feels good. And towards the left, now if we're towards the left, so if j is 0, if j is 0, then 0 count. Yes, it's right. It's going to be the size minus 1. That's the total number of zeros. Because size is actually no. Because when we do 0, this one's not counted. Right, this one's not counted unless we get 1 more. And if we get 1 more, then the total minus 1, that's the total number. That makes sense. And but the pre-index, current index minus pre-index. So pre-index maybe a -1. So the 1 count is going to be the current index. Maybe, yeah, maybe it works. Like, let's say we put a -1 here. So 1 count, pre-index is -1. So just current index plus 1, right? Current index plus 1 is the total number so far, minus the 0 count, the total number of zeros. That makes sense. That's the 1 count, which means we don't have to do this anymore. Okay, so this is my lambda, and then I can go through every single one. We have a cumulative. So this is equal to 1. Plus, if I is 0, it's going to be 0. Otherwise, we're going to do the previous one. That looks fine. If it's 0, then what we do is we add it first. Right, we add it first, and then we call this function. All we do is get a total 1 so far, which we don't even do. We do the total ones so far at I. Right, that's what we do, the total 1 so far, and then extra 0. Now if it's 1, so we need to first get the extra ones. So extra 1 is going to be this, and if Well, 0 will never be empty. It will never be empty. So I can just directly call dot back because it's -1. So right, so if it's empty, it's just be +1, and whatever it is, +1 will be correct. Otherwise, it's gonna be the back, and then 0, 1, 2. Yes, so that's number of ones, and then we can do 1 + 2 plus all the way to extra ones. So this makes sense. And then we don't have to do this. All we need is, so we don't need to do this. We don't need to do this unless it's -1. It's -1. We shall check. Right. So if this is the back is larger or equal to 0, right? If it's -1, that means we don't have anything else. We don't have to do it. And then what we can do is we don't need this. We don't need this. We just need cumulative 1. This is going to be 0 in the C star back. Okay. The total ones at that position, and then we'll do the extra ones. Okay, let's give this a shot. So it's slightly different. It does feel a little bit simpler, but we'll see if it works. So the answer is the same, but I feel like this is cleaner. But that's tested. At this point, there's no other way to do it except for doing the 0, 0, 0, 1, 1. I believe that was the one. Yes. Here is going to be, I forgot what was this, and then it's gonna be S. And then what we're gonna do, we will put a so we're going to do, this is 17. No, I think it's 15. Okay. All right, time to debug this baby. So we have 0 indices and be like this, and cumulative counts. We don't have any. This is the function. Okay, so what we're gonna do, I think we'll go with 2. If it's no, cumulative I is going to be a 0. If it's a 0, yes. 0 and this is push in. Okay. Then I go here. I go in. All right. So total ones is going to be 0 because I don't have any extra ones. Is 0. That's correct. Count is 0. And current index is going to be 0. So J is going to be 0. Okay. And pre-index is going to be by itself. No, pre-index is -1. Yes. So 0 count is going to be 0. Size is 2. 2 minus 0 so it would be 1. Right. 0 count is 1. Total 1 is larger than yes, so we return count. Cool. Okay, so result is 0. Next one, I think this will be 0. Next one is going to be 0, so it's 0, 0, 0. Okay. Cumulative count. 0, 1, 2, 3. So now we have I is 3, 0, 1, 2, 3. Okay, I is 3. Now we have a 1. So we go here. Okay, and then extra ones. 3 minus 0 down back. So extra 1 is 1. Yes, I have 1 extra 1. So 1 plus, so it will be 1. Correct. And then 0 down back. Yes. Okay, so now we're gonna go in this. Okay, so we have so 0 indices is this, okay, and current 0 indices back is 2, okay, and then J is going to be index minus 1, so J is going to be 2, so pre-index is going to be 1. Okay, pre-index is 1. So 0 count is 1. Total 1. Oh, total 1 is 0. That is not true. Oh, okay. Total 1. Total 1. Need to be the current number of ones. Now I see. Okay. Then we don't even need this. All I need is just total 1. So this total ones. Then we just do total ones plus equal to this. We don't even need this. And then we'll do this as a total ones. Yes, because we have to include the new ones, because the whole string includes all of them. Here's the same total ones. I don't know. Let's take another shot. The first one's right. The second one is wrong. But we see improvement. We see improvement. Okay. That's not bad. Let's do another round of debugging for the second one. Okay, let's do this. Okay. So total 1 is 1. No. Extra 1 is 1. Rest is plus 1. It's back, no. So go to the next one. So that's still 1. 0, yes. So we push in. Good. And we're trying to do this. Okay, let's go in. Current is 0. Current index is 1. J is gonna be -1. No, J is gonna be 0. So pre-index is -1. That's fine. 0 count. 2 minus 0 minus 1. So 0 count is 1. Total 1 is 1. So this is no. So we say 1 count. Okay, 1 count is current index. Minus previous index is 2, minus 0 count is 1, so it's 1. So we have 1, 1. Yes. And 1 required. extra one. We have extra one is 0. So one required is going to be 1. Right, one required is going to be 1. So one count is 1. One required. One required. So current is 0. That's not true, right? Because 1, 0 is allowed. One required. It's the minimum number of ones, right? We need a 1, 1. And then, so maybe what we're missing is not one required, minimum 1. Let's call it min 1 required. Right, so it's going to be 1 count minus min 1 required plus 1. Because if it's the same amount, that should count, right? So if the min 1 required is 3, and I have 3 ones, that should be 1. If I have 4, then I have 3 and 4. So this probably is the missing piece. Okay, let's give this a crack. Oh, 18. Now we overshoot it. Oh my goodness. Okay. Why? One count. Minimum 1 required. Oh, I see. I think we have to do this, right? If 1 count is large or equal to minimum 1 required, then count plus equal to 1 count minus minimum 1 required plus 1. Else, there's no else. Right? It has to be larger or equal to. If it's smaller, then it's not possible. All right, let's try this one more time. How's this one go? What the hell? If 1 count is larger or equal to the minimum 1 required. Isn't that right? Huh? I don't know. Minimum 1 required. Because the 1 has to be larger or equal to this value, right? So I minus the extra ones, which means the number ones has to be larger or equal to this, right? And then let's go back to the drawing board. Yeah, it's not ideal, but we just need to go back to the drawing board, fortunately. All right, so we know the beginning. It's 0, 0, and 0, and then here it's the first one. Next one is 1, so the rest become 1. And then this, and then we'll go in. Count is 0. Current is 2. J is going to be 2. because 4 minus 2, yeah, j is gonna be 2. And then pre-index is gonna be 1. So current index is 2, 0, 1, 2. Yes, everything's right. 0 count is gonna be 1. That's good. Total 1 is 1, so I skip this. 1 count. Current minus previous, so it's 0. So we don't have any 1 count, right? We don't have any 1 count. And the minimum required is gonna be 0, right? So this says this is larger or equal to, so yeah, we'll do this. So this is 0, 1, right? Current plus 0, 1. Now j move forward, so pre-index becomes 0. Yeah, pre-index is gonna be this one. And then the 0 count should be 2 and 4. So now we return. Done. Good. So now rest is 1 plus 1. Rest is going to be 2. That makes sense. And now next one is going to be 1 again. Right? Be 1 again. Extra 1s is going to be 2. Yes. So rest will plus 3. So this will give me 5. Oh, this is not right. Here is not right. Starting from here, so wait, hold on. I only have 5. I have 1, 2, should be 3, 4, and 5. So this should be just 1 and then 2. Yes, so it's just extra number of 1s. It don't have this. It's just extra 1s. Because you have 1, 2, 3, because ending, right? It's ending right here. Okay, so what we're gonna do, I'll just delete this part. What the hell? Oh, we're almost there. I feel we're almost there. Okay, so it must be the last part when we get in. So extra 1s is going to be 2, right? So extra 1 is 2. And total 1 is 2 as well. So we shall get 1, right? We shall get 1 here. And this is 2, like 1 and 2. So originally we have 1, 2. 2 plus 2 is 4, right? It's 4. And yeah, so 1 count is going to be 0. So minimum 1 count is going to be -1. That probably is the issue. Minimum 1 required. So I have 1, 0. So minimum 1 required should be 0. This is a -1. Okay, so here I think this is where I need std max 0 and this, right? So if the 1 count is larger, then we don't need anyone. We just need 0. And then this is good. Okay, so let's do this. I think this is probably the last piece. I'll call this is the last piece. All right. Let's see. Oh, we're getting close. We're getting close. We are 625 out of 881, but it's much better than what we have been doing in the past. Okay, we at least start passing test cases. It's not too big. I think we can go through this example. So we'll do it tomorrow.